Hello student, today I am going to teach you about the string matching technique, that one of the very popular algorithm, that is called the Rabin-Karp algorithm. Rabin-Karp algorithm is the algorithm in which for performing the match, what we do, we take help of the modulus. In it, suppose there is a pattern string and there is a given string and we want to match. There are n number of elements in the given there are n number of elements in the given string. Suppose like this, there are n element and there is a pattern string. This is called the input string. Input string, and there is a small pattern string. Suppose this is having an m element. This is the pattern string. Okay, then what we do, we start traversing from the left to right, and for each time we place a pattern string over the input string, we perform one thing. We take the modulo, we take an element. How we take that element is a different questions, but suppose there is a number q, then this we take the mod of this element, mod for pattern mod q. This value is taken, this value is stored. Suppose this value is equals to k. Then we take for every combination, or when we place or shift the given pattern string over the input string, we find out the modulo of each element. Suppose there are an element, suppose here are element n1, n2, n3 and n4. Suppose there are 5 elements m1, m2, m3, m4, m5, and here there are 5 elements n5. So when we check that, then what we do, we take the mod of these numbers. N1, N2, N3, N4, N5, mod Q. Suppose this is a number, and we take mod of number M1, M2, M3, M4, M5, mod Q. Right? And then when we compare these two, if these two are same, then match. If these two are not same, then shift by one position. Here it is in this technique there is a change, that in the named string matching we shift one position at a time, and in this we perform matching element one by one element, and if and this is very slow technique. The name technique is considered as a very slow technique, but in the Rabin-Karp algorithm, first we take the modulo of the pattern string, and then we take the modulo of the corresponding element of the input string. If these two modulos values are same, then we declare that there is a hit. There is a hit or there is a match. We say that also, consider it as a hit. And if these modulo values are not same, then we declare that there is no match. In that situation, we shift by one position. Then what is the advantage? The advantage is that if we do not get the same modulo, then we stop comparing one element, one to one comparison, and we simply shift. We just take the modulo in it, we take the modulo of the whole string, and we start comparing one by one element to the of pattern and input string where there is a hit condition. Or if there is a hit situation, then even after that there are two possibilities. Since there are varieties of number, and it is quite possible that the two numbers with respect to a given number q may have the same modulo. For example, 25 mod 3 is equals to 1. Okay, but 7 mod 3 is also equals to 1. Both, but the number 25 and 7 are not same. Here 3 mod 25 mod 3 is equals to 1 and 7 mod 3 is equals to 1. But in this situation we can clearly see that if the mod with respect to a common number is same, then we cannot say that this is the sure hit. So even after the mod value matches, we declare it as a hit situation. But the actual hit, there are two types of hits: the actual hit, or and another one is the spurious hit. The situation when the mod is the same, but there is no one-to-one corresponding match between the pattern string and the input string, then that is called the spurious hit. And when there is a match between the modulo value and there is also a match between corresponding element, then that is called the valid hit. So again, the hit situation is of two types. So I am just summarizing all this, that what is the basics of the Rabin-Karp algorithm. It is better than the naive string matching, because in it, first what we do, we find out we take a common number q with respect to which we find out the mod value with respect to the pattern string and with respect to the all possible combination in the input string. And where there is the same modulo value for the pattern string and the input string, we declare that value as a hit position. Now, after getting the hit position, we find out where are the valid hits. The position of the hits where one-to-one matching occurs is considered as the valid hit, and where it fails is called the spurious hit. So this is the basic working of the string Rabin-Karp algorithm. But how does it work through the algorithm? To understand it, first I shall explain about tell you about the honor rule. To understand this, I shall first explain you the formula that is used. But to first understand that, I have first take an example so that you can understand that actually what it is all about. So I am taking a string example. The string is 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3. Suppose this is the input string. It may seem to be a little bit longer, but it is required to understand. And we have a pattern that we have to find is 26. Then what we shall do, we shall create a parallel array for storing the mod value. Right? Now we take a number q is equals to 11 and find out the mod for the pattern number. The mod of 26 mod 11 is equals to 4, right? The mod of the 26 is equals to 4. Now we shall calculate the mod value for all the positions that could be where a matching conditions arises. So for here 31, we shall take the mod with respect to q is equals to 11. So 31 mod 11 is equals to 11 and 22 and 9. So we shall store a value 9 here. Now after this, these two number 14 with respect to 14 mod 11 is equals to 3, and we shall relate the position also, right? And after that 41 mod 11, so 41 mod 11 this equals to 33 and 718, right? For this position, after this 11 mod 15 mod 11 4 and 59 mod 11 4, right? And 92 mod 11 88 and 4, 26 mod 11 4, 65 mod 11 10, 53 mod 11 9, and 35 mod 11 2, 58 mod 11 3, 89 mod 11 1, and 97 mod 11 88 9, and 79 mod 11 2, and 93 mod 11 5, right? So I have calculated the mean value for all the possible conditions. Now I shall check out where the mod value is 4, because the pattern string, this is the pattern string M and this is the input string N. So I shall check out that where the match has occurred, means where the mod of the input string is same as the mod of the pattern string. Here the pattern string mod is equals to 4, and for the input string there are positions where 1, this position, 2, 3 and 4, there are 4 positions of match. So there are 4 hits. But whenever we get a match situations, then what we do, we start 1-to-1 comparison. For this position where we have got 4, when we compare these numbers, the number matching 2 with respect to 1, 2 with 1, no match, so we shall discard them. So this one cancel. Next position of match is 4. Now the matching is 5 with 2. This is not there is no matching, so this will also be discarded. Now there in this position 9 with 2, no match, so this will also be discarded. But for this 4, the number is 26 and there is a match. So this position will be a valid match. So this is the valid hit, and these 3 are the spurious hit. So this one is the valid hit and rest of the positions are invalid hit. So that's the basic of the Raven-Karp algorithm. So I think that this can be quite understandable by all of you. Now how to design an algorithm to implement the same logic. To implement the same logic, we have to understand the honors rules. What is this honor rules? In this honor rules, the rule is honors rule. honors rule is Ts is equals to 10 into Ts minus 10 raised to the power m minus 1 Ts plus 1 plus Ts plus m plus 1. First of all, we shall understand what this rule is all about. Right? Here, S is the shift, represent the shifts. Right? And M is the length of the pattern string. Length of pattern string. Right? And so what this honor rule shifts the next condition, then how does it work? For example, if there is a number 3141, right, and we want, and now our string was suppose 26, right? First we shall match this string with, first we shall match with this one. Later what we shall do, we shall we shall move to this position. So in the first comparison was 31 and the second comparison was with 14. How could we get the next string? The honor rule is all about this. In this, what we do, we suppose there is a number 314. Then if we, in this formula, what we are doing, we are 10, here Ts is equals to the string that is under scanning. So under scanning the string is 31, right? The string under scanning is 31 minus 10 raised to the power m minus 1. Here m is of length 2. So this would be equals to 2 minus 1, right? And Ts plus 1. S is the shift, means total shift plus 1. After shifting Ts plus 1, if this is the shift, this is considered as a shift. S is the position of shift, this is S plus 1, this is S plus 2, and like this. So S plus 1 would be the first element of the scanning, the term being scanning. So this would be equals to 3. Ts plus 1 would be 3 and Tsm plus 1 means the shift S is at this point, right? S is at this position 0, then S plus 1 would be at this position, first position, that is 3. Now the next term is S plus M plus 1. S is here, the length of the string is 2 plus 1. Plus 1 means the next one is 4. Here then this is equals to 10 into 31 minus 10 into 3. 10 cross 3 plus 4. So this equals to 10 into 31 minus 30 plus 4. So that's equals to 10 plus 4 equals to 14, right? So that's equals to 14. So with help of honors rule, we slides over the given input string. We scan one number and after that we move to the next number. Now for a given string, if the length is equals to n and if pattern length is equals to m, then we can at most shift up to the n minus m plus 1 position. Why? Because if the length of for successful comparison, at least the length of the input string should be equals to the length of the pattern string. So whenever, so we need not to compare for the n minus m, more than n minus m comparison shifts. So maximum shift would be n minus m plus 1. after that we should stop, because it is of common sense that we cannot compare two string of different length, or or we cannot get the same string for the pattern string of different length. Okay, so the maximum number of shifts that would be equals to n minus m plus 1. So now I am going to write the algorithm for the Raven-Karp algorithm. This is a little bit lengthy, but just I am going to explain you. Right? So that is the algo of the Raven-Karp algorithm. Here, n is the length of the given text string, m is the length of the given pattern string. Here, n is equals to d raised to the power m minus 1 mod q. Here, what we are doing, we are taking the number d with respect to m minus 1, we take the calculate, q is the number with respect to which we are finding out the modulo. There is a relation between with which number we are taking the mod. There is a relation, and that relation is a different term, different thing that that is not under BTech syllabus, and we are not going to discuss that. But that term is calculated, and that d is the length, because we should take the d such that it covers overall length of the pattern, and it created equally over the parent pattern and the text string. After that, from the very first position, what we do for 1 to m, we take the mod of the pattern string and we take the mod of the pattern string and text string. Like we have created two arrays and we have calculated the mod value sorry, corresponding to the pattern string and corresponding to the every possible condition of the text string, and that I have already shown you. Here we are calculating the, for the full length we are calculating the corresponding mod value, and after that this is the crucial step for s is equal to 0 to n minus 1. This is the number of the shift. As I have told you, the maximum possible number of shift is equals to n minus m, because after that there is no possibility of match, we shall check out when there is a match. Do if P is equals to TS. If the TS is equals to the P, means the pattern string and text string are same, in after mod are same, then that situation we match all the element one by one. If the match occurs, then we declare that the pattern occur at shift S, and if S is less than n minus m, then what we stop comparing and leave that position. If this can and if S is n minus m, then we keep on forwarding to the, and like the honors rule we have studied, with help of which we take the next combination and we do the same for the next string. So that's all about the Rabin-Karp algorithm. So its complexity depends upon this terms. So the complexity is O(n minus m theta n minus m). Depends upon the complexity, right? Or corresponding to each match, we shall will be this is the number of iteration, and each after iteration the maximum amount that it can take. That suppose for after that we compare to the, this is the worst case complexity actually, because the length of the pattern is equals to m. So for every shift, if we are doing the complete match, then the maximum number of comparison would be O is equal to theta is equal to n minus m into m. So this is the worst case complexity, worst case, right? So that's all about the Rabin-Karp algorithm. Thank you.